Okay, welcome. Oh, um I need to do this for where is it? Here I am, and then going live and just trying to share this. Where am I? Save post? No, I need to share. There we go. Uh just doing some housework right now. Let's see. I gotta find my group. Okay, so my group. And I think that's it. I don't think I can post on my um I wonder if I can post to my page, share to a page. Oh yeah. There we go. Okay. So here we are. Um Thank you for joining me to learn more about Abacus. And it's open. It's open office. Just if you wanted to if you have any questions, let me know, and I will answer them into the chat. Um, what are we talking about? We're talking about Abacus. The Abacus is a counting tool. It's a counting tool, but it's also an adding, subtracting, multiplication, and division. And so here is my Abacus. This is my teacher's Abacus, and my teacher's Abacus um, helps me teach, obviously, because it's a lot bigger. And so then the kids can see the abacus from a distance. So if you're a teacher and you want to learn how to use the abacus, this is how we do it. And the first thing we need to do is actually we need to learn how to read the abacus. So before we can do anything, we need to learn how to read the abacus. So all the lower beads has a value of 1. So 1, 2, 3, 4. This is how I know that this is 4. How do I know? Well, when the beads are touching the beam, this is what's counted. So we know that this is 4. When they're not counted, when they're not touching, this is 0. So we have 2. We know that 2 beads, because they're touching each other, right? All the beads are together. This is 2. And then this is 3, 4. And then, so if you notice, there's not enough beads for 5, right? There's not another bead for 5. So 5 is actually this. This is 5. So we have 5. All the top beads will have a value of 5. So that would be 5. This is 5. This is 5. Well, the difference is the how the place values are on the abacus. The place value on the abacus talks about the columns. So the columns itself is what tells us what value it is. So this is the ones column, and then this is the tens column. So when we do 1, this is also 1, but it's not, kinda. This is 10, right? Because we want to make sure that our 0 is over here on the ones column. So we have 10 because it's 1 and 0. But if we do this, this is 1. If we do this, this is tenths. It's a little bit difficult to say, but it's tenths. And so if I move my marker, this marker tells me where the ones place is. I can move it to here, and then we're at ones. So this is the ones place. This is the ones place. That's the tens, and then this is the 100. So going back to here, this is 5. So if this is 5, then this is 50. If this is 50, then this is 500. All the top bead will always have a value of 5, no matter what. No matter where you are, it will always have a value of 5. 1, 5, 5, 5. It just depends on where your column is. So 5, 50, 500. Okay, so we're back to here. And so when we want to do 6, that's 6. We know it's 1 bead on top because it's a 5, and then plus 1 is 6. So we have 6. And then when we count, it's 7. We know it's 2 and 5. 2 and 5 is 7. So this is also introducing to the children how to decompose what 7 looks like. There's many ways to do 7, right? But on the abacus, this is how we do 7. It's a 5 and a 2. And if you have any questions, go ahead and put it in the chat. So then we have 3, 5, I'm sorry, 8. 5, 6, 7, 8. How do I know? How do I know that this is 8? Because this has a value of 5, and then 1, 2, 3. 5 plus 3 is 8. And so if we take away the 5, it's 3. But if we add the 5, it's 3. So then this is also introducing the children how to count on, because we count from here 5, 6, 7, 8. Counting on is the process of counting not from one, not from one. So that's what counting on is. And Abacus introduces this. I mean, you could go here and do 6, 7, 8, and then 9. So that's 9. So what's after 9 is 10. And we talked about it. What is 10? It's a 1 and a 0, depending on what our place value is. So we have 1 and then 0. So this is 10. So let's see. This is how we talk. So this is 10, and then we have 11, and then 12. And then we have 13, 14, and then 15. Remember, 5 will always be the top bead. So we have 15. We could do this, right? What is this number? This is 65, right? Or we have 565. So that's how we read the abacus. Once they know how to read the abacus, then we can actually start doing adding and subtracting. And so I have my book. I have my book that is available on Amazon to, oh, maybe I should not mirror. How do I not mirror my, there we go. Mirror. Okay, good. So this is my book that I have on Amazon where we can do the abacus. And so we start off with the book is learning what the numbers and the relationship of the numbers, right? So we know that and we're only talking about like the numbers between 0 and 9 in this book. So in the book we have 5, and then what's before 5 is 4, what's after 5 is 6. So the idea is to know the relationship of the book, to know the relationship of the numbers. And so it goes into, this is really preschool. And so I talk about, what's greater than, what's less than, how to count forward, how to count backwards. And that's all in the book. And so there are activities. Let's see if we can do the activities. So we have activities where this is all my activities that I created. And then, I mean, I'm still going through it. And after that, we also start talking about adding and subtracting. So on the book, in the book, we do adding and subtracting. And then I have an abacus class. Let me talk about the abacus styles. So we have different abacus. That was my teacher's abacus. This is a student's abacus. I like this one because it's colorful and it differentiates between the different values. So we know that the blue bead is 5, right? It's just easier to see as opposed to being kind of dull and boring. This is what's used. There might be more columns. The more columns just means that there's more digits. So it depends on how big the digits are. It depends on how big your numbers are. It's the same thing. Each of them, these two, they both have a dot in the middle. So there's a dot there. There's a dot there, and then this one has a dot. Where's the dot? There's a dot here. There's a dot in the middle, and then there's a dot here. So the dots signifies the location of the ones place. So, or it could be the thousands, right? So there's a thousands over here. So if I do the ones over here, if I do ones here, then the thousands would be over here. And then this would be 100,000. So there's 100,000 and then thousands and then ones. So so depending on how big your number is, you can actually start from here, which is the ones place. You can start the ones place, but then you'd have all of these numbers, all of these columns as part of your number. Or you could do it this one. I like this one because the students that I have, they're younger. They're about 3, 4, and 5. And this is just to help them, because they like colorful things. I like colorful things. And so I like to use this one. And then when they graduate, when they get older, then we can start using these ones. So that is a little bit about the student's abacus. With the student's abacus, you want to lie it down, right? And you want to be able to move it like that. But it has to lie down on the table. That's the one thing that some people didn't. One of the things that was mentioned that they didn't understand, how come the beads don't stay up. Well, the beads don't stay up because it's meant to lie down. The other thing is that I read that it's very quick. Like you can actually move it and it doesn't. You can actually move it and it doesn't stay. So you have to be careful. This is why working with an abacus, you have to be intentional, right? Because the minute you do this, then all of your beads will look different, right? You'll get the wrong answer. So that's why you have to be careful. When you work with the abacus, you ideally hold the abacus, right? Hold the abacus with your left hand so then you can work the abacus with your right hand. And that was one thing to understand, is to be able to make sure you hold the abacus still, because if you don't, it will move and then your answer's gone. Then your answer's gone. So I know, like, when if the kids are in person, my my brother, who's also a abacus teacher, he'll move them just because they don't have it, they don't hold it. So if they don't hold it, there's a chance that they'll lose their answer. So just be careful when you work with the abacus. Make sure you're holding it with your left hand. Now, here's the thing. Why do we hold with our left hand? We hold with our left hand because ideally you do calculations with your right hand. You do calculations with your right hand because the left brain does calculations. So that's the idea with the whole, like, visually you could see, right? You can, if you're left-handed, you can work with it. You would just I'm just thinking, you can work with it, but you still, if you're left-handed, you still need to hold with your left hand, work the abacus calculation with your right hand, and then you write with your left hand. You could still do it. That's not a problem. I mean, that's if you're writing anymore. We don't write as much. But anyways, but you can have it where you hold the abacus and you hold your pen or pencil and you work the abacus and then you write the answer. Do the question and then write the answer, right? So that's the idea for that. That is, oh, so this is the student abacus. And this is another abacus. This is a different, it just looks different. I don't see this one as much. This one's kind of a rarity. But then there's also this one. This one is a Chinese abacus. How do I know? Well, if you look, there's 2 beads on top and there's 5 beads. 1, 2, 3, 4, 5. There's 5 beads on the bottom. And so they're different. It's let's see. And then but there's not too many that looks like this. I noticed the reason why we have the beads like this and not rounded like this, because this is used for um abacus competitions. There's actual abacus competitions, and the abacus competitions, they use these ones. The reason why is because it's easy to flick, whereas this one is not so easy to flick. But also, there's too many beads. It's a little redundant right here. If you have any questions, let me know. Let's see. Do I have any questions? Ah, sorry, just checking to see if I have any questions. Okay, so how do we work this? Let me see if I can flip you over. Flip camera. Okay. So let's see. Is it this one? Nope. That one. All right. Okay. So here is my abacus. And then this is a little, maybe I should have gotten the, anyways. Okay. So on the Chinese abacus, we have one, we can choose any of these columns, right? I'm going to go back to my student abacus. Okay. So let's see. Okay. So on the Chinese abacus, we could still count 1, 2, 3, 4, 5, right? We have 5. Well, on the Soroban, on the Japanese abacus, we can do 5. That's 5. So notice that the beads in the beam, it's still, the concept is still the same. The beams and the bead, right? Oh, there we go. Oh, that's so much better. Okay, so now it's a little redundant on the Chinese abacus because we have this, that's also 5. Whereas this is only 5. So there's no confusion. So this is 5 or this is 5 on the Chinese abacus. It's a little redundant. We do have where we can do 6, right? So that's 6. 6, 5, 6. So you know on the Chinese abacus we do this, but then they have to do this to make it 5. And then we do 6, 7, 8, 9, 10. Okay, great. This is 10. That's 10, right? So we have 5, 6, 7, 8, 9, and then 10. So 10 on the Chinese abacus is there's a little redundancy here because there's here, which is, let me see if I can lower that down. There we go. Okay, so we have the Chinese abacus where it has 10. This is also 10 because how do I know? Because every top bead is a value of 5. So we have 5 and 5. 5 and 5 is a value of 5. So we know that this is 10. So it's a little redundant that this is 10 or this is 10. But then that's also 10. How do I know? Because we're in the next column. The other difference is because I don't remember, let's say I have a little brain fart and I don't remember what column I used. Um, I would tend to go here then, go to this side and make sure that I don't have a question on where I'm started. So I have 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10, 10, or 10. I hope that was okay. So whereas on the Japanese abacus, I have this dot that tells me where the ones place is, and then I can go, if I have decimals, I can go back here, or if I can go here. So like when we're working with the Chinese abacus, you still have decimals. You just have to remember to start over here. So if we're doing money, right? This is $1, $2, $3, $4, $5, and then this is 10 cents. Right? How do I know? Because I imagine that my decimal place is over here. That's the difference, right? This one's an older Chinese abacus. There might be some newer ones. I don't know. I'm not sure. Okay. So that's the difference between the abacus. And then if we do 10, it's still 11, 12, right? That's 11, that's 12. And 13, oh no, sorry, here. See how it was supposed to be here. This is actually cents. So 10, 11, 12, 13, 14, 15. And then 15, 15 or 15. So this is always going to be 15. So then we have 16, 17, 18, 19, 20. Okay, this is where it gets interesting. This can be 20, this can be 20, or this is 20. Yeah. So there's the difference between the Chinese abacus and the Chinese abacus and the Japanese abacus. So that's a little bit about that. So let's do oh, so I have an online class. My online class is $20 a month. However, how do I know if the kids are doing it right? Well, it is up to it's up to the parents' discretion. Because why? Because it's a self-paced it's a self-paced class. Oh, I should show you my class. I'll have to do that next time. So, okay, and then let's see. So it's a self-paced class. Let's see. I gotta turn you over. Flip camera. Okay. Is that, yeah. There we go. So it's a self-paced class. We go through the questions. We go through this. There's this one, and we actually do the adding and subtracting towards the end. And after that, we go into my next book, which is learning how to do the 5. Right. we're learning how to do the +5 with the 5 frame. And there's activities on how to do it with the abacus. So this is abacus driven. And so I have that one. And then I actually have my +10 that I'm doing as well. Okay. So I do have a class. It's $20 a month, and it is self-paced. So it's up to the parents to make sure that they're holding the abacus correctly and so forth. If you're looking for something more interactive, like more, you want to be have a class one-on-one with me, I do offer that. Just let me know, and I can send you more information on that. Oh, okay. So what I wanted to do was I wanted to talk about working memory and long-term memory. So Abacus does a lot of like long-term memory. And the reason why is because we do a lot of the questions. When we do questions, let me see. I need to find, so there's so I have this was part of my class. So on my class we also do tic-tac-toe. The idea here is that they understand how to answer the questions, and then they put in the numbers. So a lot of my activities is math oriented, but it's abacus oriented. I do have where did it go? Oh yeah, okay. So we do practice more questions. Oh, there we go. We do practice more questions, and so we do. There's more than just like 2 lines. This is 3 lines, and then I do have questions that are 4 lines. The reason why is so then they can see how the numbers work. But notice we do a lot of questions. Why? Because we want to put the numbers, we want to put the abacus into long-term memory, not in working memory. So ideally, I have these activities where they can do like 1 page a day. So this is my next book that I have where we're working with the +8 family. If you have any questions, let me know, and I can answer any other questions. So, oh, what I did notice is when we're teaching abacus, when we're teaching math to children, I noticed that we do a lot of result-driven result-driven questions. So here is one. Let me see if I can. Okay, so flip camera. Let's see if this works. Okay. Okay. So if you noticed, we have 1 plus 7. So 1 plus 7, it will be 8. How do we know? Well, okay. So on the abacus, oh, I wonder if I can do it this way. No, 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 no. Okay. So we're back to here. On the abacus, so I don't know. It's interesting. So when we do with the abacus, we are actually building blocks. So I don't know if you could see, but we have 1. We add the 1 here, and then the question is, maybe I'll do that. Maybe I'll do that. Maybe I'll do this. No. Okay. Anyways, I'll fix it later. So we have 1. So the question is 1, and then 7. So we add 7. How do I add 7? 5, 6, 7. So we add 7 like that. And but notice the answer is
plus
but
7
I don't have to worry about
equals
I don't have to worry about formulas. So here we add 8. Okay, great.
8.
So now what's the next one? We have 2. 2 on the abacus. Where is there we go. So we have 2 on the abacus, right? And then we want to add 6. So we add 6. We have 1 bead on top and 1 bead on the bottom. So we add 6. So it's easy. This is what we call simple. The reason why we call it simple
2
abacus is because we don't have to worry about any
plus
formulas.
6
So we have 2
equals
and then we add 6. 5, 6. Okay, great. So we have 8. So notice the first question was 8, and then the second question is 8. So it's result driven. Okay, it gets a little, we keep
3
going. So there's 3 and 5.
plus 5.
So, no. No. It's this one. Okay, 3. So what do we do with 3? We have 3 and then we do 5. All we got to do is just add the 5, just like that. Then,
5
so what's the answer? The answer is still 8.
equals
So again, this is the result. The result is the same. Right? We have the different ways, and it's kind of interesting, right? And if you noticed that we did 1 plus 7, 2 plus 6, and
4
then, but now we're doing doubles. Okay,
plus
before we do doubles, the question is 4 plus 4. On the abacus, we don't do doubles. On the abacus, we actually do, there we go. On the abacus, we actually don't do doubles. We learn the building blocks on how to use this 4. Notice we don't have any more beats to add the 4. There is a way to learn how to add 4. Now, instead of learning 4 plus 4 is 8, that's something we had to memorize. Instead of doing that, what we should memorize is how do we add 4 using a 10? So this is where the 10 frame come in, and we do, okay, how do I get 10? If I do 4, how do I do 10? Well, 4 plus 6 is equal to 10. And so this is the next step. We don't actually do double. We don't actually do 4. What do you call it? We don't actually do doubles, because learning doubles is a one-hit wonder. So the idea for this is to make sure that we understand how to work the number 4, because once we have 4, and we understand how to move it, then we can do it in any other way. That's my dog. So 4 plus the 10. Oh no, we want to do 4 plus 5 minus 1 is 8. So we know that, oh, sorry. So we're doing the 5 frame. The 5 frame is 1 plus 4 is 5, right? If I have 4, there's 5. There's 1. 1 is kind of hanging out. So we know that this is part of the 5 frame. When we want to do, we don't have enough beats to add the 4, so we can utilize the 5. This is how we start teaching the kids how to analyze specific steps. So instead of learning just 4 plus 4 is equal to 8, we tell them, okay, is there enough beats to add the 4? Is there enough beats to add the 4? No, there's not. So what else can you do? You can use the 5. So these are questions that you can prime the children to start thinking ahead. Okay, if I can't use any more beads down here, I can use the 5 bead. To do the 5 bead, I could do 5. I add the 5, but adding 5 is too much. So I have to take away the 1. So ideally, we're using the 5 frame, and yet we're taking it to the next level. We're taking it to the next step. So instead of learning that 4 and 1 is 5, okay, great. 3 and 2 is 5, okay, great. But now we're actually utilizing, if I have 4, how do I make it to 5? How do I make it? So then my answer is 8, right? Okay, so let's see if I can do it this way. If I do it this way, okay, yeah. So here is the question, right? The question was, can I do this? 4 plus 4. Oh, maybe I can't. Oh, it's too much. Okay, so we have 4 plus 4. So we do 4, and then we know 4 plus 1 is equal to 5, right? Oh, there we go. 4 plus 1 is equal to 5. So what do? Well, we take this and we move it to this side. So it's a -1. So when we rewrite the question, it's 4 plus the 5 minus 1. Let me rewrite that. 4 is equal to 5 minus 1. So we add the 5 and we take away the 1. I don't know if you can see that. So that's my next book, actually. The reason why is so then this is the next level. So, okay, let's take this one step further. Let's take it one step further and we do 3 plus 4. We do 3 plus 4. Okay, 3 plus 4. Well, if we learned our doubles, right? If we learned our doubles, we needed to remember that 4 plus 4 is equal to 8, and then we have to take away 1. You can do that. Or you can learn your other doubles, which is 3 plus 3 is equal to 6, and then you have to add 1, right? These are stuff that you can remember. Or what you could do is learn your abacus, which is this. We only need to remember, not only, but we need to remember that if we add the 4, it's equal to plus 5 minus 1. So this is versatile. It's more versatile. Yes, yes, Jennifer. Doing this way will help them build algebra as they get older. You're absolutely right. Because what did we do in algebra? In algebra, we actually talk about substitution and we move around our equation. So the idea, oh my gosh, that was brilliant. So the idea here is once we know how to add the 4, right? We can add the 4. We have our abacus. We have our 3, and then we plus the 4. We add the 5, take away the 1. This is the fundamental things that we would need to remember, right? This is the fundamental making sure that we understand how to do the 4. So let's do it again. We can do it with 2, right? If our question is 2 plus 4, right? The idea is to remember that we have this 4, right? This 4 is what is the common thing between all of the questions that we have, right? All of the questions that we have, 4 plus 4, 3 plus 4, and then 2 plus 4, right? So in 2 plus 4, okay, what can we do? Well, again, we can talk about our doubles, right? We can do doubles, 4 plus 4, and then we have to take away 2. So that would be 6, right? Or we can do 2 plus 2, right? And then plus another 2, which is 6, right? Because this would be our doubles. You could learn that. That's not a problem. Or we can go back and we could do, on the abacus, we could do, let's see, make it a little brighter. So we could do 2. There's not enough to add 4. So what do? We utilize this 5. We have to plus the 4 is equal to plus 5 minus 1. We say plus 4 because the idea is to substitute this plus 4 with this equation. So we do plus the 4 is equal to plus the 5 minus 1. And that's what we were doing it. What a great way to learn. So math in the higher levels is more easily understand. Yeah, that is true. Man, I need this when I was young instead of memorization. Oh yeah, that's right. I remember when I was a kid, we had to memorize. We had to memorize our doubles, and then I remember like one of the kids. I was tutoring this one. I was like 5th grade or something, and I was tutoring this. No, I wasn't 5th grade. I think I was like 3rd grade or something because I was still in elementary school. And I remember to memorize our doubles. So one of the questions was 7 plus 8. And one of the kids was having a problem. They would have to count it, right? 7, 8, 9, 10, 11, 12, 13, 14, 15. So they would have to count it. And so I tutored a kid when I was young to learn my doubles plus 1. That's what I had to learn when I was a kid. So I had to do 8 plus 8, right? And then take away 1. So that would give me 16. So that was how I did it. I mean, I liked math, but I didn't want to have to go through that. So if we're doing this as a question, so we have 7, 8, right? Well, here is what we talk about. But instead of doing the 5, how's another way to do it? Well, we know that 8 plus 2 is equal to 10. We move, so this is where absolutely right with the whole algebra. We move, right? We need to move it over to here. Why? Because this is our equation and our equations needs to be balanced. So if we take away 2 here, we take away 2 here. Let me rewrite the equation and it looks like this. 8 is equal to 10 minus 2, right? Because why? This is 0, 2 plus 2 plus the 2 plus minus 2 is equal to 0. So there's a 0 over here. Okay. So now it's it gets a little it's the investment to understand how to use it. Once they get it, they will work, it will go quickly for them. So, but for right now, because I'm explaining it, it's going a little slower. So we have 7. And then, is there enough beads to add 8? No, there's not enough beads to add the 8, right? Because we have 7 here and we have 2 beads here. So what's another way? Well, what we need to do is we need to add the 10, take away the 2. So we add the 10, just like that. We add the 10 and we take away the 2. So my answer is 15. So that's the fundamental idea of understanding how to add and subtract on the abacus. So, oh, um, let's see. Let's see if there's any questions. Just checking, because I'm trying to go live on TikTok as well. Maybe I shouldn't do this. Okay. Anyways, okay. That's all right. No questions. Oh, and my okay. All right. So there's no questions. But so that's the idea for understanding. Oh, and that's my dog. So that's the idea of understanding the formula. So oh sorry. So my answer is 15. Just to button it up. All right. Thank you so much for joining me, Jennifer. I'm so happy you're here. Hopefully this helps. And I was talking about how happened my books. So oh, we can talk about this. We can talk about this one so this is the beginning of my of the class. I have class. I do have classes available, or you can go through the book. This book is available on Amazon, um, and I made it in color, but the other books are not going to be in color. Anyways, so I have it where um, uh, uh, I learned something. You're welcome. I learned something new. Fantastic. Let me see if I can. I'm learning how to use StreamYard, and this is fantastic. Okay. So in the beginning of the book, we start talking about how to read the abacus. The thing here is how to read the abacus. Oh, let me do the other one. Let me do that one. Oh, and there we go. So, the first thing, because it's not. I mean, when we do the bottom beads, it makes sense, right? The bottom beads make sense. It's when you get to the top bead where it's just like, why is there a top bead? Well, the reason why there's a top bead is so then this adds to 5. So this is 5, 6, 7, 8, 9. So in this book, we only go from 0 to 9 because I only wanted to stay with the one column in this book. The beginning book that I'm going to be creating, I'm going to actually update this. I will be oh, maybe I should put in a banner that says this. Yeah. Okay, cool. um, if you want to know more about my abacus class, I do have a class online. You can sign up with Easy Math. This is a 4 video series on explaining like concrete. We talk about concrete math and abstract math and um, concrete and physical. Concrete. I have to remember now. Concrete, physical, and something. Um, The reason why is because abacus is concrete. It's a physical thing that you can see. So, so that was the other thing, is understanding, like, we can actually do is counting on. So, yes, I am learning as well. I'm learning as well. Um, so going back. Okay. So counting on, my mind is all over the place. I didn't quite um think about this in my head. Uh, Counting on. Well, one problem is we have. I don't know if I printed it out. I didn't print it out. The counting on. Counting on means we don't want to have the kids to count from one. We want them to be able to count from whatever. So we. I don't know if you know, but we there's a grid, right? There's a table, right? There's a table of 100. It goes one, oh, let's see, right? That, right? There's a whole grid, and it goes 2, 3, 4, 5, and so forth. I will print out next time I do this. And we're supposed to take this number here, 10, 13, 14, 30. So then the idea was, if we give them this number 23, can they count on from there? Well, Abacus makes it really easy, because how do we know? Well, if when the kids remember 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then this is 10, right? That's 10. We know that this is 11, 12, 13. They see that this is 13. They may not remember the word 13, because 13 in English is very difficult. But here, when we do 23, right? When we do 23, well, they know the next number over would be 4, right? So they just need to add the 1B to make it 24. So the reason why I feel it's interesting that Abacus helps counting on, because you can see it. The kids can see that this is 24, and then after 24 is 25. So instead of learning these, because numbers are symbols and not all symbols make sense. So having the abacus, because it can also grow with them, right? Because you can actually do multiplication and division. But the idea here is, because you pick a number from the abacus, because you pick a number, you can use the abacus to help them count on. So if I said 45, right? Um, if I did 45, 45, what numbers are, what's after 45, and what's number 4 and before 45, right? So we have 45. If when they know to count on the abacus, it's 46 and then 47. They just need to add the bead. So when they're doing 45 and they want to know what's before 5, they know that it's 4. So 44 and then 43 is before 45. So the cool thing about abacus is that it will help them see the numbers as opposed to seeing the symbols of the numbers. So that's one thing. And then the other thing is also understanding the place value. So I know that this is the ones place and this is the tens place. So then when we start talking about 10, 20, 30, 30, 40, 50, right? We have 10, 20, 30, 40, and then 50. So going back to the to my book, we actually, after we do uh, comparison and talking about counting backwards. So we count backwards, we count forwards. Counting forwards is easy. I have it where, you count what is between. So I give you the number in the abacus, right? And the abacus here is 9. So if it's 9, right? What is between 9 and 7? Well, we take away the 1, and that is 8. So we write 8 here, and then 7, and then 9. So then the idea for the book is to make sure that they understand what the numbers are surrounding. So we have here, I have a mushroom hop, and then the other one, which is, yeah. So I have mushroom hop. Oh, cloud counting. So if I give you the number in between, what is before and what is after? So that is part of the making, understanding the relationship. So that was one of them. And then then I have it where they talk about the bigger than and less than. And again, I do bigger than and less than. And then this is also to get them to understand how to use the arrows. It took me a while. Like I don't use the word alligator, like who the alligator is opening and closing. I don't use that. I do the numbers. I like it where the bigger number has the two dots and the lower number has the one dot, and then that's how you figure out what the arrows are. So if the number is bigger on this side, then it goes two dots on this side and then one dot on this side. And so my there's two online classes that everybody starts off with. Either they start off at preschool understanding their numbers, or they go off and then they learn how to read the numbers, but then we go quickly into adding and subtracting. So that's what the introduction to Abacus is, where we talk about adding and subtracting. I do it by number. I do one number at a time because I want to show how it's being used. I want to show how the numbers, how each number is moving. So here we do plus one. When we add one, right? If I have seven, I only need to add one. If I want to take away, I could take away this one bead. I wanted to make this abacus class simple and easy to understand, and it'll be quick for the kids to get and understand. So okay, we're at 45. Okay. So because when we add one, they think this is one, but it's not, right? This can be one or this can be one. I wanted to, and that's why I have like my numbers plus one. I just wanted to show that if they add a bead, it can be any bead, it can be any bead from the bottom, if that makes sense. So it's any bead at the bottom. So that's how I wanted to, cuz we get into a point where sometimes the kids are like, "No, this is one over here." It's like, "No, if I want to take away one, I can take away one from anywhere from here. From here, from here, from here or here." And it's the same thing with adding. I can add this bead is 1. I can add if I have 7, this bead is 1. So that was the idea of adding the 1. And then it goes into 2. I do have other activities to make it more engaging. So this one is follow the boxes, and then I have a puzzle that I already made. um, and then I have a plus 3. Plus 3, the questions are not so, there's not too many questions for plus 3. So if I have 5, I want to add 3, right? If I have 6, I want to add 3. I want to add 3 beads. These are the 3 beads. So the concept of, incrementing the idea, incrementing the learning. And I think that's what we need to do. I don't know. Slowly introduce the numbers instead of just saying, here's a bunch of numbers um like like this. So we have a bunch of numbers, but there's no relationship to them. Whereas on the whereas this one, there are relationships. Like I want to add the 3. So when we add the 3, it's not so that's what it is my book is not result driven. It is building blocks driven. So we have the plus 3, and then there's a plus 4. And then after 4, we do minus. Why? Why are we doing minus? Because I wanted to talk about taking away before we start talking about the plus 5. Oh, yeah. So I wanted to do that. And then so that's the next set, which is minus 1, minus 2, and then minus 3. And then I have like activities to help engage, because not just boring questions. And then this is the follow the boxes. Any questions? No questions. Any questions? Nope. Okay. So we have the minus 3. After we minus the 3, then there's minus 4. And again, there was another puzzle, and I don't know what happened to all my puzzles. My puzzle pieces. Okay, so then we have a plus 5. Plus 5 is when we start doing the upper bead. We utilize the top bead, and then we do the 6, 7, 8, 9. But none of these are using formulas. The formula happens so after the preschool, this preschool one. So we have we have plus the 5 and then plus 6, right? So we're adding 6. We have 2 plus 6. So that was, the reason why. So we have 2 and then 6. They need to know that it's one beat on top and one beat on bottom, and you put them together like that. So that's 6. If we have 1 plus 6, we know it's one beat on top and one beat on bottom. This will always be the case, right? So we do 3 plus 6. We do one beat on top and one beat on bottom, and we bring together. So the reason why I have broken up my questions and my book like this is so we could see the different variations of adding 6. And that's it. Those are the two beads that we add, right? But it doesn't matter which bead as long as it's 6. So as long as I do this, this is 6, right? So we have 6 and then 7 and then 8 with what activity? Oh, the who would win activity. And then here I have 9. So then when we add the 9, the opposite of adding is subtracting. So after adding, we subtract, right? We have to learn to take away the 5. We add the 5, we take away the 5. Why it it's helpful? Why? Because because the kids see that we're removing it. So when we minus the 1, take away the 1, add the 1, take away 1, add the 1, take away 1, they could see that we're actually taking the quantity away. Okay, 9 more minutes. So that is my book. You can get my book on Amazon. Or you can go to my class. I have a class that talks about this, or it talks about like adding and subtracting. My class, and then after the preschool abacus class, the next one would be the plus 5 with who. Plus 5 with who talks about the adding, utilizing the 5, utilizing this 5. So just as I told you about the 5 formula, sorry, the 5 frame. I go into understanding how to use the 5 frame. When we talk about it, we say plus 4 because we're trying to add 4, and we're adding 4 to the question as opposed to learning our results, right? We don't learn our doubles. We're learning the building blocks of understanding how to use a 4. So if I wanted to do 1 plus 4, I just add the 5, take away the 1. So the idea is to see the pattern, right? Abacus math is a lot about patterns. So if I want to add 2, how do I plus the 4? I just plus the 4 like that. I don't know if you can see that. Let me use my bigger abacus. Can we do that? Okay, so we want to do 2 and then 4. 4, like that. So the idea is this is what 4 is. When we want to add 4 and there's not enough beads, we want to add 4. So if we had this, right, we can just, we have this. So we add the 4. So notice there's a pattern between the top bead and the bottom bead. We want to add 4. This is the motion. So the good thing about the abacus is that it also provides finger movements. And it's muscle memory. And this muscle memory is going into long-term memory and not working memory. So when we go through the book, when we go through the curriculum, when we go through learning how to add and subtract on the abacus, it's not just look at the number and do it. It's what is the pattern, right? What is the pattern? And what is the memory to go with it? So there's a working memory that happens. So that's the adding of the 4. I have too many abacus on my table. Okay, there we go. Much better. So when we have 3 and we want to add the 4, notice that there's a pattern. It's one bead on top and one bead on the bottom, and we add it like this. And I kind of like it because I like making noise. Anyways, so the idea here is to add the 4. We want to plus the 5, take away the 1. That's what adding 4 is. And then it goes into the others, right? It goes into what plus 3 or what plus 3 is. Plus 3 is the same concept. What is the 5 frame for 3? Well, 3 and 2. Well, 3 plus 2 is equal to 5. How does that work? Well, we want to add 3. There's not enough. I need to add the 3. I can add the 5 minus the 2. And that was the concept here. So that's what this book is. So it takes the plus 5 frame and it pushes to the next level. Like it really, what do I want to say? It's using the 5 frame and making it to the next level. Like it's advanced usage using the 5 frame. It's great that they learn how to do what 5 and 2 3 and 2 is 5. It's great that they know it, but then we actually use it in Abacus. So, I hope I don't this was kind of like all over the place, and I apologize. If you have any questions, let me know. I'm going to sign off and say thank you for joining me again. Thank you, Jennifer, for joining me for today's lesson and just talking about just Abacus. And if you have any questions, and this is on replay, let me know and I can get back to you and answer all of your questions. If you have any, yeah, I'm going to make this more regular. If you want to learn more about my Abacus class, you can sign up at learningwithlynette.com. /easy math, and that will send you a 4 video series on why Abacus is beneficial, and it talks a little bit about my class. Or you can just follow me. I will go. Yeah, I also have books. So I have this book, and then my other book, and then I'm still making some other books. So all about Abacus. And if it's fine if you don't. I try to make my books self-explanatory that you don't need to go through my class. But if you want to go through my class, I have it available. All right. I should sign off. Okay. So thank you for watching, and I will see you next week. I'll see you next week. Bye. Uh, New messages. Oh, flip camera. End stream.